Hello everyone, thank you for joining me, and I'm here to talk to you about this hot topic in React community from over some time, state management libraries, which are the best. So, I'm Adrian. I work at Allegro. I'm front-end engineer and I have big soft spot for data visualization. So most often I build dashboards. And I learned that complex interactive dashboards require a lot of state, and I worked with it a lot, so I would like to share my experience with you, show you how you can evaluate different libraries, how you can pick best for your use case, or maybe even build one from scratch. So we will look at the complexities of the state management. I will briefly introduce you to popular solutions, and then we'll do some evaluation. But it won't be a direct comparison between these libraries. I just want to use them as examples to illustrate my point. Global state is shared state between multiple components anywhere in your application. So that's really simple, but it requires a lot from your state management library, really. It needs to store data somewhere. We need some API for reading this state, and not only the whole value that we put inside, but sometimes we need to derive some state. Maybe we have a query string in our state in one place and list of products in another. So we want to be able to calculate the filtered list of products. Then we need API for changing the state. Sometimes we need to enforce some contracts around the state, so some more logic here. And finally, synchronizing changes with the UI. When we do some changes, we need this library to push them to React so we can see them on our UI. The main mechanism for this is through rendering components. So some state changes, we render component, and we render whole subtree. But with global state, it can cause a lot of problems. Our naive solution would be to lift our state up to the application root, and then whenever we do any small change in our state, we'll re-render the whole application. That's a lot of wasteful re-renders, a lot of wasted work. So our library needs to be smarter. We need to be able to tell which components depend on which part of the state. So then we'll be re-rendered only when those part changes, not when anything changes. Finally, we need to set up our state in our application. We need some tools for this. So first, Redux, classic library. It has this idea of global state object. It's immutable. We can put anything inside. And we have reducers that can manipulate it. Reducers are pure functions, so they calculate new value of the state, and Redux is responsible for updating it. But to run reducers, we need to dispatch an action, possibly with some additional data. So we have this nice separation between why something changes and really how a change occurs. Mobx, newer one, it has this idea of observable state object. So we can import this object in our component, subscribe to it, and Mobx will take care of re-rendering our component. So first we need to take some constructor from the Mobx and wrap our data with it. It will augment it with some proxies and some new JavaScript magic. But in the end, it will track which properties are we accessing, and it will later notify whenever this specific properties changes. So we have this fine-grained control. And I think the newest addition to popular libraries is Recoil from Facebook. It also has reactive atoms, but first we need to break down our state to smallest independent parts. Then we put each part in separate atom. Then our components can subscribe to these small atoms. Of course, when we have some complex data, we need to model more complex state. So we can do this with this graph of relations between atoms, this data flow. Okay, so I divided the evaluation in 3 topics. We'll go one by one. So shape of the state, what we can put inside, change propagation, and setup. First question is what we really can put inside our state, what state library can store for us. Luckily, most libraries let you put any JavaScript object. Sometimes there is this assumption that this value will be immutable to squeeze more performance, but in the end, it will be treated as this opaque value. You put inside the state library and you get the same object back. That let us store data of any complexity, but also more sophisticated objects like state machines or even whole databases. But reading whole state value is often not enough for us. We need to derive some state or select specific portion of it. Redux introduced this idea of selectors, pure functions, again, previous presentation, helpful, that accepts whole state as an input and calculate new state value. Redux uses exactly this. Selector in Redux gets whole state as its argument. In Recoil, we decomposed state earlier, so selectors in Recoil can accept multiple atoms as input. And they will be recalculated whenever any of the atom changes. So we are still in sync. Mobx has this theme of collocation. It tries to add most of the complexity on the state object itself. So we derive state using computed properties. They are implemented as regular getters on the objects. Then we need to change our state. Recoil goes for simplicity. It's just like use state hook. We can pass new value. We can pass updater function that will calculate new state value. Mobx, again, named methods at the state object. You can clearly see the API. There's also a place for enforcing some constraints around your state. And Redux, we have this decoupling of actions that present and that represent why we want something to change, and reducers hide this implementation detail. Okay, we changed something, we want to synchronize it with UI, and as I said, it's really important that we'll do this efficiently. So Redux reuses selectors. You write your selector by hand and then use in your component. Then, because selectors are memoized, Redux will notify your component whenever this value changes. Mobx does this all automatically. You don't need to write your own selectors or track anything. You just access specific properties in your component, in your render function. Mobx will track which properties you are accessing, set up some subscriptions behind the scenes, and later will notify and re-render your component whenever these properties change. But rendering is only part of the story. Sometimes we have some third-party widget that we need to update in more imperative way. Maybe we have some API to call, like tracking service. So we need to react to state changes outside of the render loop. So we need to have some function that will be called whenever state change. Recoil, again, by simplicity, let you define the effect function on your atom that will be called whenever state changes. So you can put your all side effects here. In Mobx, we have, again, more granular control. We have reactions, functions that can read from multiple reactive state objects, and we have this fine-grained tracking. So this function will be rerun only when accessed properties change. In Redux, we really can't subscribe to state changes. We can subscribe only to dispatched actions in your middleware. So we need to have more knowledge about our domain. We need to know which actions affect which parts of the state. But in return, we get more information in our handlers. We have this intent, why something changes. We can do some optimizations there or some decisions. And very important issue is where state is stored, really, because it affects consistency in some way. Consistent UI is very important in the case of global state, because two components can read the same part of the state, but they can be presented on very different parts of the page. So we need to show them the same information. We can keep our state inside React, just like Recoil does. That way we have this consistency out of the box. Because local state in React supports concurrent mode, supports batching, so we have all guarantees automatically. Redux and Mobx, because they are older, they keep state outside of the React. So these libraries need to implement this bridge between React and their object states. Right now it's much simpler. We have in React 18 this nice hook use sync external store, but still it's added complexity in these libraries. And finally, state setup. First, we need to introduce state to our application. We need to inject it so components can read it. First way is using context providers. We import provider from library. We wrap our application tree inside this provider, and we achieve full flexibility of React context. So we can, for example, override some values in subtree, or maybe override values for testing purposes. Mobx, for example, keeps state objects in module scope. So to use them, you just need to import variable and you are ready to go. But please remember that these are just global singletons and have all downsides of this solution. So testing is much harder. We added state, we need to initialize it. Simplest case is if we have some constant that can pass to this library and it will work. But sometimes we need to do some additional work. Maybe we need to fetch something from the server like API keys. Or maybe we need some information from the browser that's hidden between asynchronous API like index2db. Here, really, Recoil provides a good solution for this. You can define initial value as a promise. So you do your work inside the promise. And because Recoil supports React suspense, you can suspend whole application till your state resolves. Redux and Mobx really doesn't have solution for this. Of course, somewhere during initialization, you can fire your promise, and in when function you can trigger another state change, but you are doing this by hand. And also you need to handle the loading states, because it's really outside of the scope. Another issue is late initialization. Maybe your application grew much bigger and you introduced code splitting. User navigates from one page to another, you load another code chunk, and in new code chunk you also have some global state. So you need to merge them. You have this state from previous page that you don't want to reset, you want to keep it around, but also you have some new state that you need to initialize. Here, Redux have good solution. There is this method, replace reducer, that does exactly this. It keeps old state, but for new reducers, it runs the initial function, initial action. Recoil really avoids this problem. First, it assumes that you divided your state already. So whenever you load new code chunk, it should be new state and you shouldn't touch old state. But even if you have some dependencies between atoms, you have some fancy selectors, their dependencies are defined with string keys that identify specific atoms. So only thing that's common between your code chunks are string keys and nothing more, no real references. And of course, there is this usual stuff that's common for any new dependency. You need to check documentation, how good it is, how hard it is to introduce new members to this library, what's the size of the community and ecosystem, is project maintained, is it funded, does it meet your performance budget, how hard is debugging, and maybe there are some developer tools, and so on and so on. But to focus on state management libraries, check what shape of the state it supports, what are the APIs for reads and writes, how it handles change propagation, can you do this efficiently with this library, and does state setup functions really support your architecture choices. So, thank you everyone.